Let's talk through some things to consider before you install a server operating system. It's not as simple as buying just any hardware that you want and then installing any server OS that you want. There are a few things to take into account before you purchase hardware or before you change what operating system is on your server. For example, not all server hardware has drivers and support under all operating systems. Some servers are designed to work with Microsoft Windows Server. Others are designed to work with Linux, specifically like Red Hat or CentOS, and therefore there are drivers specific to those operating systems for that hardware. If you're curious what operating systems your hardware supports, check out a hardware compatibility list. That will list all of the different operating systems and all of the different hardware configurations that that particular server is capable of supporting and what software is available to unlock certain features. For example, on some servers, different levels of RAID are available for boot drives depending on what type of operating system you're using. Now, just like in our desktop world, we typically install operating systems from a DVD or a USB thumb drive. However, there's one major difference, and that's in deploying virtual machines. Now, typically when we move a virtual machine on desktops, it's usually a file that can be copied from one machine to another. However, when we use virtual machines in a server environment, usually those are considered infrastructure virtual machines. And they look a little bit different. They don't transfer quite the same way as desktop virtual machines do. So we need third-party tools or tools provided by the developer of that particular hypervisor in order to help us move those virtual machine images. As you prepare to install an operating system, start thinking about what the resource needs of that particular operating system are and compare it to the server that you have. Do you have enough memory, enough disk space, enough CPU cores for the service that you're trying to offer? Once you've decided that your hardware and your operating system are compatible and going to offer the services that you need, it's time to install. Now, most modern operating systems have some sort of a wizard or a walkthrough on how to install that operating system on the hardware. Feel free to follow through that, but think through each of those steps carefully. Sometimes the default option is not the only option or not the best option to take. So read those options carefully, make sure you understand what each step of the process is doing, and take appropriate action. For example, disk partitioning. If you want to keep your operating system files on a partition separate from the data of that particular operating system, make sure that you set up those partitions while you're installing the operating system. It's significantly more difficult to resize or change partition layouts on disks, drives, etc. after an operating system has been installed. Now, virtual machines make that a little bit easier, and it's much simpler to add and remove different volumes, but it's best to do this during installation time. Also during installation, you'll have to come up with a name for your server. Now, many people name their computers. Windows 10, for example, has an option to change the name, but usually comes with some default name. Realize that a server's name is particularly more important than a desktop computer's name, specifically because that server's name may be used to reference the services that that server offers. And so the server name needs to not only be memorable, but be associated with the service that is being offered. So be careful when you name your server and make sure that it's a server name that makes sense for the services being offered and also is appropriate for the environment that that server is being deployed in. Once the base operating system is installed, oftentimes there will be a post-installation configuration necessary to get the roles and features up and running on your particular server. Be careful to walk through those steps and make sure that you install and add all of the roles and features that your server is going to need. Now, of course, most server-grade software products, server-grade operating systems, are going to require some sort of license key. If it's Microsoft Windows, that key will be typed in during the installation process. If it's Red Hat, that license key may be added later. If it's an ESXi installation, you have to input that license key through the vSphere client. Whatever it is, keep in mind that you will have to use a license in order to keep using that product. Many server operating systems come with a very lengthy trial period, including Windows Server, which has a 180-day trial period. If you decide to use that operating system in a production environment, make sure that you have installed that license key prior to that trial period expiring so that you don't lose access to that server. Once the server is up and running, we'll oftentimes move it to a rack. And at that point, our keyboard, mouse, monitor are going to be disconnected. And so we won't have the same ability to just manage that server from a keyboard and mouse like we're used to doing. Realize that most servers still have some form of remote desktop. So if we need to make changes, we can remote in and make those changes across the network. However, if you need for some reason to access that server's hardware while it's in the rack, realize that a KVM switch, or a keyboard video mouse switch, will allow you to interface with multiple servers from a single keyboard and mouse. These are very common in data centers or areas where you have racks of servers in order to consolidate the amount of peripherals that you need, still be able to interact with a large number of servers. So if you need to make BIOS tweaks or changes to RAID volumes, which you shouldn't do on a regular basis, but if you need to do a task like that, there are options for getting that keyboard, video, and mouse input into that computer. Of course, it may be useless to have that capability since many of the services that we're going to configure have remote access or an ability to configure them from another device. Typically, we call that in-band administration or OS level management. So things like RDP or Remote Desktop Protocol or SSH, where we're directly interacting with the running operating system, is an in-band administration. And out-of-band administration actually uses the features built into the server motherboard for state of health information, things like IPMI, or on the HP servers, the integrated lights out. Dell has one called iDRAC. Both of these fall under the category of lights out management, which means that you can actually turn servers on and off, manipulate server settings, etc., all through those special interfaces to the motherboard. Of course, if you've been in IT for any length of time, you know that documentation is critical. Imagine having a rack full of 1U servers, 42 1U servers, and all of a sudden a drive goes bad. And you've got to figure out what's the size of the drive, what's the speed of the drive, when was it last replaced, where do I go to get a new one, and then you need to actually physically install that drive on that server. It's going to be a lot easier if you have a document somewhere that tells you when that server was purchased and all of the pertinent information. Similarly, if somebody complains that your website is down and you don't even know which server your website is hosted on, it's going to be significantly harder to troubleshoot and get that service back up and running. Among the things that we like to document are asset lifecycle. We want to make sure that our servers are not run longer than they were intended to run. Now, most servers have a lifespan of 5 to 10 years, depending on the environment. Drives, however, only have a lifespan of between 3 and 5 years. So keeping track of when servers were installed, when hard drives need to be swapped out in order to make sure that they don't fail while the system is in use is important. Past just the initial purchase of that equipment, we need to monitor it, make sure that it is actually functioning correctly, and if drives do fail, proactively change them out so that we don't end up degrading a RAID array. At the end of an asset's lifecycle, it's important to document the process of decommissioning that server, moving the services that that server was providing off to another device, and then making sure that all of the data is properly backed up or archived so that nothing is lost when that physical device is removed. Along those same lines is asset inventory. So not only managing the life cycle, both the commissioning and decommissioning of the server, but also making sure that we know what's what. How many hard drives do we have in the building? Software inventory also. What keys are we using for which pieces of software on which servers? Server operating system licenses can be very expensive, to the tune of $5,000 for a single server license. Making sure that you know how many licenses you have available and where they are can save you thousands of dollars by making sure that you have the right licenses on the right hardware. Of course, depending on the size of the environment that you're working in, it's also appropriate to have things like networking diagrams. How are these servers actually connected logically to the network, and physically, where are they? It's important to have data flow diagrams, understanding how the data is moving from server to server. Imagine, for example, a storage area network where we have one large server that's holding all of the data for multiple servers. We need to know how that data gets to those individual servers to make sure that there are no bottlenecks in that system. Documenting a baseline is also important. For example, what is the typical system temperature under load for this server? If we check that in a year and notice that the average temperature is significantly higher, it may indicate that that server needs maintenance, perhaps some dust cleared out, so that the server can run at its optimum performance without wearing out its parts. We also want to know what version of the operating system is installed, what level of patches or installed updates are present, so that we know what the system was working with when it was commissioned. And then, of course, we're going to spend a whole unit talking about disaster recovery. Documenting recovery plans for each physical device, each service that's offered, can also be very important. Now, while servers are running, there's a number of tasks that we consider maintaining the servers. First and foremost, we're going to need to make sure that our software stays up to date, which includes operating system patches, software patches, installing new versions of software if necessary. There are 3 different types of software updates available. A hotfix is a small update that can be applied while the operating system or the software is running. A patch is a slightly more significant update that may require a system reboot or an application to shut down and restart in order for it to be applied. And lastly, a service pack is a grouping of updates or a significant change to an operating system or application, which will definitely require at least one restart of either the computer or the application, but may require more. A neat feature of the Windows Server environment is the Windows Software Update Service. This is a service that you can run on a Windows server, and it can actually act as the update server for all of the Windows 10 or other Windows servers on the network. So rather than downloading all of the updates from Microsoft for each computer, you can download those updates once to the server, and then that server will then spread them out to the computers that need them. This is particularly useful for administrators who don't want specific updates applied to computers, either because it doesn't work well with that particular hardware, or it breaks some software that's needed, or the update itself is known to be buggy. The administrator can actually stop that at the server level, their local server level, and prevent that update from being applied to all of the other machines. Similarly, the administrator can also enforce which updates are forced on the computers inside that network to make sure that all those machines are up to date. Aside from the software maintenance of a server, there's also several things that we can do proactively on the hardware side to ensure the uptime and longevity of that equipment. Things like cleaning out dust from fans and heat sinks can be an important step to prolonging the usefulness of a server. Checking uninterruptible power supplies and making sure that they are still providing battery backup services to all of the servers that are connected to them is also important. The key here is to replace things before they fail. Now, while we include redundancy just in case something does fail while the server is running, it's always better to replace a part before it fails than have to react and replace a part after it's failed. So one of the common practices that I do on servers is if there's 8 hard drives, I plan out over a 5-year time period which drive is going to be replaced every 6 to 12 months. That way we're replacing one drive every 6 to 12 months rather than all 8 drives every 5 years, and we replace all of those drives before their 5-year warranty is up. Now, most of those hard drives would probably last 10 years, but this way we can be sure that those drives are significantly less likely to fail because they're newer than the drives that they were replacing.